I'm going to turn this off just so it makes it a little bit bigger contrast. Hi. Introduce yourself.
Hello, I'm scientist Freddie Ortman. My first observation that I would like to share.
Put it on the camera.
Sorry.
Sorry.
Is 13. And I observed that when I put the needle probe in the flame for exactly 30 seconds, the tip of the needle probe was placed on the candle and immediately went through the candle and caused steam to rise out of the candle or the needle probe. Another of my observations that I would like to share is I said when I placed a spare piece of wax into the flame, the piece of wax turned black and the wax started to change from a solid to a liquid.
Do you have an idea about why it might have changed black? What do you think? Is that any ideas?
Maybe because that the flame is so hot that when something is placed on top of it, it causes things to like burn, I guess.
Okay.
And then my experiment that I would like to share is, for my first experiment, I blew out the candle's flame 3 different times and relit the smoke coming from the flame in order to relight the candle. The first time I blew out the candle, which produced smoke, I waited for 5 seconds. Then I held the lighter over the smoke and the candle immediately relit. The second time I blew out the candle and waited 10 seconds. I held the lighter over the smoke and the candle relit, but it took a little longer. And the third time I held the lighter over the smoke after 15 seconds and the candle did not relight at all.
What do you think about that?
It's pretty cool.
Any ideas about why you didn't light the third time?
Because since I waited 15 seconds, all of the smoke coming off of the candle had already risen and there was really none left to be lit, I guess.
Okay. All right. Thank you. Everybody, I appreciate it.
Thank you.
Good job, Freddie.
If you guys will just relax a little bit and just talk. All I want you to is talk to the class, okay?
Zach, come on.
Talk to
Oh,
the
let me
class.
just like,
Do it for Bella.
Introduce yourself.
I'm scientist Zachary Kupiak, and for my first observation, I took a slow-mo of me blowing the fire out, and the fire had disappeared into smoke within 0.3 seconds. And then for my next observation, I observed that when I put the other half of the candle into the fire and dropped some wax off of it, the wax became very hard and stuck to the table within 2 seconds.
Say it again. Did what? Became hard.
Oh yeah, the wax became very hard and stuck to the table within 2 seconds.
Okay.
And for my experiment, I put my candle onto a plate and poured water all around the flame. I then placed a clear glass over the candle and it created a vacuum that sucked up the water from the outside of the glass and blew it out.
So you think that the flame sucked? Why do you think it would suck the water up? And you don't have to know the answer. I'm just asking, what do you think?
I don't really know.
Anybody else, as scientists, anybody else have an idea?
Could you restate it, Zach?
Okay, you had a plate and put some water in it, and they lit the candle, right? And you light the candle.
Yeah.
And then you put a flask over the top of it?
Yeah.
And then, so did the candle go out?
Mm-hmm.
But what happened to the water?
It I don't know, it just like went away. Like, I don't know really.
I thought you said the water went up the flask.
Yeah.
Oh yeah, it's created a vacuum that sucked up the water from the outside of the glass.
How do you know there's a vacuum?
Because it like blew it out.
Blew it out. It blew the candle out?
Yeah.
All right, what do you think? All right, thank you.
Uh.
All right, next, you come on deck, you come on deck.
Oh, Sam.
You introduce yourself.
Hello.
Oh,
Oh, my name is. Oh, should I put that there? I
yeah.
put my name over there. My bad. My name.
It really wasn't until the early 1900s that they started calling people scientists. Before that, they were called natural philosophers. Okay, go ahead.
Hello, my name is Daniel Norris. I am a natural philosopher. My first observation that I would like to talk about was the wax portion of the candle. I took the needle probe and I scraped it on the side, and it cut into the wax, pushing portions of shavings out, leaving gashes on the side of the candle where I scraped it.
What was your observation of? You told me what you did.
Mhm.
So what was your observation?
That the closer I was up to the top of the candle towards the wick, it was easier to scrape, and then further
Was this
down.
a lit candle?
Mm-hmm.
Okay, so you had a lit candle and you scraped some down the bottom, some in the middle, and then some near the top?
Yeah.
Okay, I get it now.
I lit the candle, and I observed that the wax melts. I mean, the flame melts the wax around the wick, and it creates a small bowl shape with a pool of wax. And the bowl or pool is not the whole diameter of the wax, but it's 0.5 centimeters from the edge on one of the sides, and on the other, it was 0.3 centimeters.
Ah, okay.
And then my experiment was, my second experiment was that I took a candle and I lit it and placed it on the table, and I took a beaker with nothing, just a plain beaker, and set it over top of the flame and timed it to see how long it would take to go out. And so the first time it took 18.6 seconds, and then the second time I breathed into the beaker and then placed it over top of the lit flame, and the second time it took 12.19 seconds. And then the last time I put the beaker over the flame and I put it towards the edge of the table so I could put a straw in, and I started blowing in constantly while the flame was lit underneath the beaker, and it took 8.7 seconds. And so from this, my conclusion was that the first time there was no outside sources affecting the flame, and so it just went out on its own due to lack of oxygen. And then the second time, when I blew into the beaker before, when you breathe out CO2 and oxygen, but mostly CO2, and so that was taking the place of where the oxygen would be for the flame to use that up. And then the last time, when I was blowing in my CO2 that I breathed out, was just taking up the space that the oxygen would be in more quickly than the second time.
That's an interesting experiment. Very good, thank you. All right, one day. Thanks for that.
Hi, I'm natural philosopher Tim, and for my two observations, I have when the candle was lit, there was an immediate crackling sound. The wax immediately started melting and dripping down the side, and the flame appeared to be leaning towards the left. And then I noticed with the smaller wick, there's a much smaller flame. And for my experiment,
Can you go back on that second experiment? Observations are.
yeah,
So when you use the word smaller, I'm not sure what you mean. So what was the normal size? What was the smaller size? How much are you talking about? What was the regular wick's length?
it was, let me see.
Remember how we talked about making observations better? You can't, if you just say bigger or smaller, if you put numbers to it, I can see it, but, so you're not sure how long the first wick was, but it was longer, right?
Right.
And then, did you cut it in half? Did you cut it in thirds? What did you do?
I cut it 2/3 down.
Okay, so only 1/3 remained, right?
Right.
And it was smaller, how much smaller? size of the flame, the regular flame?
Probably half the size.
That's the size, and I think I would have added some measurements on that to make it
Yeah.
better. Okay, what about your experiment?
In my experiment, I got a new candle weighing at 62.69 grams, and after burning for just 5 minutes, just regular candle, it reweighed at 62.12 grams, so like not much changed. And then I put 8 matches in the wick, like to make a big flame, and after burning for 5 minutes, it dropped to 49.16 grams and went down 2/3 of the size.
Can you lay that on the camera so I look at some of those numbers? It's hard, when you just say the numbers, it's hard to say. So the first one was 62.69 grams, right?
Right.
And then after 5 minutes, it went to what, 62 point?
1-2.
Okay, so about a half a gram.
Yeah.
And then you put the 8 matches in there, let it go for 5 minutes.
It was 49.16
You
grams.
have that number written down somewhere? Oh, there it is.
Yeah, my handwriting's
That's
not great.
a great deal. That's a big mass loss, right?
Yeah.
And you said something about 1/3 of.
It was,
did you measure the length of it or something?
Yeah, it was 2/3 the original.
Did you measure the length?
Yeah. I haven't written that down, but
Okay. All right, that'd be interesting too. Very good. Very good.
Good job, Ken. That's good. Good job, Ken Freeze.
Karen Freed. How do you want me to do? Thanks, Jerry.
Hi, I'm natural philosopher Bronwyn, and for one of my observations, I put that when the candle is blown out, then white specks start to form on the black burnt wick, and then I said, when there's wax on the end of a metal probe and put in the flame, then a flame lights on the wax for like a second. So there was like an actual,
I'm sorry, I lost you. Can you speak up a little bit?
Yeah.
The first one he says when the candle is blown out, white specks start to form where?
on the wick.
Oh, really? And you hadn't seen those before?
Mm.
Only when you blew them out?
Yeah.
Any idea about what you think they are?
I have no clue. Like,
That's fine. What about the next one again? When?
I said when there's wax on the end of the metal probe and it's put in the flame, then a flame lights on the wax for a second, like
So
after
you
it's
see an
taken
actual
out.
flame
Mhm.
on the needle probe?
Mhm.
Okay.
And then for my experiment, I tested to see what would happen if I added water underneath the flame. And then I covered it up with a flask, and when I put the flask over it, it sucked the water up, and the water eventually rose and put out the flame. And when I put the flask over the flame, the bubbles came out from like the bottom into the water. And when I put the flask over the candle, once the flame had gotten up to where, like, put the flame out, the water just stopped rising.
Now you had a fellow colleague who said they did the same experiment, and they used the same words that he did. He said it sucked the water up. What do you think would cause that?
Maybe like the heat, because then when I put it over, like after it had been put out for a while, I like put the flask over the candle that wasn't burning, and the water didn't rise.
What do you think makes the water come up into the flask?
The heat from
The
the
heat.
candle.
Does heat normally make water come toward it or something like that? Or what?
I don't know.
What about those bubbles that came out? What do you think about that?
I have no clue what that's from, but
And you don't have to know the answers. Everybody get that?
Yeah.
But, can we at least think about it?
Yes.
All right, thank you very much. All right, need somebody on deck. There we go, good, thank you.
Okay. I'm natural philosopher Abby.
There you go.
Um,
And speak up as loud as you can.
okay. For
Which one
my
are you gonna read?
number 18,
15?
18
I
and
got it, I got it.
21.
That's it.
So when I put tweezers at the top of the like lit wick, and like closed the tweezers, the flame like decreased and became smaller. And the farther down I moved the tweezers, the smaller the flame became.
Wow, so you started near the top and it made the flame smaller, then you what, you went down further?
Mhm.
And what happened?
the flame became really small and it almost went out.
Really? And it kept getting smaller?
Mhm.
Ah, interesting. Any ideas about that?
I guess just like the tweezers were taking away the oxygen or something that the flame needed.
So do you think near here is less, more oxygen, less, you think it's less oxygen?
I don't know.
You don't
I
have to
don't
know the
know.
answer.
Yeah, I don't know.
All right, next one.
21. The flame was like yellow at the top and blue at the bottom, and it didn't ever have a smell until I did my experiment with it. So,
Okay.
and then,
Experiment.
oh wait. So, for my experiment, I put baking soda on the flame of the candle, and the flame pretty much immediately went out. And when I relit the candle, the flame was less than half a centimeter tall, and it used to be over 2.5 centimeters tall. And the baking soda bubbled and fizzed around the melted wax, but it never caught on fire. And around 10 minutes after I relit the candle, the flame grew to about 1 centimeter. And I did this same process again, and there was no flame the second time, but the wick became orange on the top half of the wick.
Interesting. What do you think about that?
I guess just something in the baking soda, like something in it just like makes the flame go out.
Do you think if you put a different powder besides baking soda, would you get the same results, or you think it's just something about the baking powder, baking soda?
I'm not sure. I didn't try anything else, so I would have to try.
Anybody have questions? Thank you very much. Can you just take that mouse over there and shake it a little bit? On the table, on the desk. Oh, okay, never mind.
I don't know why I think time's out like that, because I know you're using it. Sorry. Sorry.
Okay. Hello, I'm natural philosopher Reese Ramser. One of the things I observed was that the wick turned almost completely black after only 2 minutes of burning, minus a ½ centimeter white gap at the bottom of the wick. And
So
then,
this is a brand new candle,
yes,
so it all turned black except for about a ½ centimeter that was near the wax, near the candle itself?
yes. And then I also observed that the melted wax that hardened in the center of the candle is a clear color instead of the original white colored wax.
So tell me the difference between the melted wax solidifying and the original. What do you think the difference in color was?
I'm not sure.
You said it's a clear color. What is the color of the, oh, white, I see, clear instead of white. Is that what you're saying?
Yes.
What do you think about that?
I'm not sure.
Okay, I experiment.
Okay. I wanted to see if the weight of the candle would decrease after being lit for 15 minutes. Before burning the candle, it weighed 224.3 grams, and then after burning for 15 minutes, the candle weighed 223 grams. So the weight of the candle decreased 1.3 grams.
In how long?
15 minutes.
Okay, 6 minutes, all right. 1.3 grams in 6 minutes. Okay, so if we divide it by 6, we can get how many grams per minute, couldn't we?
Yes.
Okay, so what do you think? Any questions? Do you have any idea, Reese, sorry, do you have any idea about why you think the candle is losing mass?
I'm guessing that some of the wax is evaporating.
Okay, what do you think, does everybody like that idea? Evaporating? So it's like going into the air, right?
Yes.
Okay. All right, thank you. All right, just go ahead. Thank you.
I'm the natural philosopher Will Wright, and my experiments were the candle appears to be in the shape of a cylinder. The cylinder goes straight up until 1 centimeter below the wick. It starts to come to a point. another observation I made was there are tiny black specks on the cylinder that appear to be just inside the surface.
Sorry again, what's your first name? Candle, what appeared to be what?
In the shape of a cylinder.
Okay,
And then
candle, okay.
And then I said the cylinder goes straight up until 1 centimeter below the wick. It starts to come to a point.
Okay, all right, next one, what was it? There was what?
And I said there are tiny black specks in the cylinder, on the cylinder, that appear to be just inside the surface.
Inside the surface on top?
Yeah, like you can see like inside the surface there seems to be black specks. You can't.
Did those specks seem to move at all?
No.
Okay, all right. All right, next, experiment.
My experiment was I wanted to see if why the flame didn't burn through the wick as fast as it should. So I cut off 3 centimeters of wick and timed it until the flame fully burned it. It took 41.42 seconds to reach the bottom of the wick without wax. Then I measured the candle and got 13.40 centimeters. Then I lit the candle and waited 41.42 seconds and remeasured it, and I got 13.20 centimeters. It means that the flame only burned 0.2 centimeters. Then I cut the wick off the candle to see if it would light while the flame is close to the wax, and it would not light. Then I held a chunk of wax over the flame to see if it would burn, and it did not. Based on these experiments, I believe that the flame reflects away from the wax, making the candle able to burn longer. The wax is also not flammable.
So the wax is not flammable. It says, I believe that the flame reflects away from what?
The wax.
Away from it, and then, what else is it?
Making the candle
Making the candle able to burn
longer.
So you think the purpose of the wax is to let the wick burn longer?
Yeah, to make it last longer. And because if you just had like a string, it would just go off in like
So
a minute.
are you, on one of your experiments, didn't you say you, didn't you light just the wick by itself? Or you did?
Yeah, I cut 3 centimeters off of the wick off,
And so did you put just the wick in a flame?
yes,
How long did that last? I find.
41.
I've done that experiment, I think you said it lasted a really long time.
41.42 seconds.
Wow. How long would it take for that much wick to burn when it was in the candle? Quite a bit longer, I think?
Yeah, when I was in, yeah, I probably would. I mean, I could like calculate that out and see
Okay.
how long
All right,
it took.
all right, that's interesting. All right, thank you. All right, next. Hang on just a minute. Yeah, go ahead. All right, thank you.
I'm natural philosopher Natalie, and my first observation is that a 1 centimeter puddle of melted wax takes about 1 minute and 20 seconds to re-solidify, and then when a candle covered in baking soda and vinegar mix was held up to my candle began to crackle and go out all on its own.
Before you go any further, you said, you had another colleague who said it only took 2 seconds for the wax to get hard. You said how long did yours take?
A minute and 20 seconds.
What do you think? That's a huge difference, isn't it?
Mhm.
When you heard them read that, what did you think?
I think that was pretty quick, but my puddle was like that big, like a centimeter big, so.
How big was it? Who had the,
I think it was Fredsky. Or Zach.
I thought it was Zach.
That was Zach.
Did you say your wax melted hard in 2 seconds?
Yeah.
She's saying it takes over a minute. And scientists can disagree. They can disagree, but is it possible you did it differently? Did you take a candle and just turn it on its side or something?
Yeah.
How did you do it?
I had like a bunch of drippings go into one place and then waited for that to become fully solid.
What's the difference, Zach? What's the difference between what she did and what you did?
I don't know, I just like made, I don't know, I just made like a drop of wax go on the table, and I timed it until
Right.
it turned hard.
So you put it on the table itself. You put yours on where?
It was in the petri dish.
So is it possible that they were on different surfaces?
Yeah.
Okay. Sometimes scientists, it's not a right or wrong. It's just, I didn't know you put it on a different surface than me. All right, go ahead.
And then my experiment was I let the candle light for 1 minute and then I blew it out, and the smoke was only visible for about 10 seconds. And then I let the candle light for 5 minutes and then blew it out. The smoke was only visible for 11 seconds. I didn't expect that because I thought it would last longer.
So you thought if you let it burn longer, then the smoke would last longer, but it didn't, did it?
No.
That's interesting. Very interesting. Do you happen to do any other times? You just did it twice, right?
I'm sorry?
You didn't do it like for 30 seconds, like.
No, I just did 1 minute and 5
Okay.
minutes.
That'd be interesting to do a series of those to see what happens. So how did you know the smoke was gone? What did you just say? I can't see it anymore?
Yeah, I couldn't see it.
Okay. All right. Thank you very much. That's interesting. Okay. Okay. You guys are real close on the time. That might be the last one. You get this one. Go ahead.
Hi, I'm natural philosopher Zoe Buffet, and for one of my observations, before I lighted the candle, I saw that the wick was white and it looked like a braid intertwined with multiple white strings. At the end of the braided wick, the strands separated a little. And for the other one, I said that the flame is aqua blue 1/2 of the way up the flame, and then ombres to a faint yellow, almost white color. For my experiment, I wanted to see if the longer you burn the candle, then the smoke after you blew it out would last longer. First, I lighted the candle for 5 minutes, and then after 5 minutes, I blew the candle out. After I blew out the candle, the white smoke from the flame lasted 10 seconds. Then I lighted the candle for 10 minutes and blew out the candle, and the smoke lasted 10 seconds. Then I lit the candle for 15 minutes, and then I blew it out, and the smoke also lasted for 10 seconds as well.
So almost identical on that.
Mm-hmm.
All right, everybody else, any questions on that? So there's something about that 10 seconds, isn't it? Okay, all right, thank you, I like that. All right, I tell you what, I think we're a little short on time, so here's what we do. How many people didn't go there, just 2? Okay, so anyway, we have our elements, final tomorrow, everybody gonna be ready for that?
Yep.
And then we'll have 2 people that have to do their presentation, then I'll say what we're gonna do next, I'll wait till tomorrow, I'll take care of that. Now, here's, if you still need time to finish, I'll be here tomorrow morning, I'll be here after school tomorrow, got that? I won't be grade these things till probably Monday, okay? But anyway, I do need to put them back here, where they belong, so I can find them, and you don't wanna lose them, boy, that's a bad time to lose them. Now, did you guys see each other doing the experiments? Yes, that kind of meeting? On your own? Oh, hey, wherever you normally put your labs, put them back there, and then, I'll know they're all there. All right, hey, thank you very much, I enjoyed that.